Okay, today we're going to look at solving more problems using equivalent ratios. Let's start by looking at example 1. A county superintendent of highways is interested in the number of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks in the local Department of Motor Vehicles, or the DMV. The DMV reported that in the month of August, for every 5 passenger cars registered, there were 7 pickup trucks registered. How many of each type of vehicle were registered in the county in the month of August? So here we're talking about cars on the road in a certain county. Okay, there's 2 different types. There's a car and a truck. Let's use C for car and T for trucks, just to save some writing. Okay, so let's look at A. It says use the information in the problem to write 4 different ratios and describe the meaning of each. Well, the first ratio we could use is the ratio that they gave us. We could do 5 to 7. And this is for cars to trucks. Okay, this is a part-to-part ratio, meaning that each section, the cars and the trucks, represent a part of a whole, not the whole total. There's another way we could write a part-to-part ratio, and that would be 7 to 5. It's using the same numbers, but this time it's trucks to cars. And this again is a part-to-part ratio. Okay, so that's 2 of the types. There's 5 to 7, which is a part-to-part, and 7 to 5, which is another part-to-part because they're both pieces of the whole. So now that we've written 2 of the ratios, we've got to find 2 more ratios to get to the 4 it's asking for. We've done 2 part-to-part ratios. Let's now do a part-to-whole ratio. We could do 5 to 192. This is a part-to-whole ratio because the part here is the cars and the 192 is the whole, or the total number of cars and trucks together. So this we call a part to whole ratio. There's one more type of part to whole ratio we could do, and that would be 7 to 192, and that would be trucks to the whole. Those are our 4 ratios, 2 part to part ratios where we're comparing the 2 parts of cars to trucks or trucks to cars, and then there's 2 part to whole ratios where you're comparing cars to the whole or trucks to the whole. Next, it asks us to make a tape diagram representing the quantities in the part-to-part ratios you wrote. Well, here are part-to-part ratios, 5 to 7 and 7 to 5. So let's start by making our tape diagram. Remember, our tape diagram just shows how many boxes for each number in the ratio. So we'll start with the cars, and we'll make it 5. 1, 2, 3, 4, 5. This is for the cars. Then we got to do the same thing for the trucks. A little longer though because this is going to have 7. 1, 2, 3, 4, 5, 6, 7. So this again is for the trucks. So there's our tape diagram showing the cars to the trucks. Next it asks how many equal sized parts of the tape does the tape diagram consist of? Well, how many parts are there? There's 5 for the cars, 7 for the trucks. Well, altogether, that's 12 total parts. 5 for the cars and 12 for the trucks. So that's going to be for our whole. That represents our whole. The 12 sections represents our whole. 5 of those sections are cars and 7 of those sections are trucks. And together they make the 12. What total quantity does the tape diagram represent? Well, what's our whole, or what's the total number of vehicles? That, as our problem says, is 192. There's 192 total vehicles. So those 12 parts now make 192 total vehicles. Okay, we have 2 more parts to look at. We're now going to start looking at answering the final question of how many of each type of vehicle there was. It says, what value does each individual part of the tape diagram represent? So if you recall from the page before, we made this tape diagram where there's 5 sections for the car and 7 for the truck, giving us our 12 total sections. Well, for that, we need to figure out how much is each in each one. Remember, the total is 192, so 12 sections makes 192. So if 12 makes 192, we need to take the 192 and divide it by 12. And that's going to get us how much is in each little section, which is 16. So in each little section, there is 16 pieces. So now, how many of each type of vehicle were there registered in August? Well, we have one more step to do that. Well, since there was 5 car sections and 7 truck sections, to figure out the cars, all we need to do is 5 times 16, which will get us 80. And then for the trucks, all we got to do is 7 times 16, which is 112, giving us our totals for each one. So let's review our steps. We first created a tape diagram to see how many sections were there for each of our 2 different types of vehicles. Then we figured out how many total sections there were. Once we figured out how many total sections there were, we divided the total vehicles by the total sections to figure out how much each little section was. And that was where we got 16, and then we multiplied the number of sections for each type of vehicle times the quantity in each section to get us our totals. Let's look at another example. The superintendent of highways is further interested in the number of commercial vehicles or vehicles used by businesses that frequently use the county's highways. He obtains information from the Department of Motor Vehicles for the month of September and finds that every 14 non-commercial vehicles, there were 5 commercial vehicles. If there were 108 more non-commercial vehicles than commercial vehicles, how many of each type of vehicle frequently used the county's highways during the month of September? Well, we have several different types of ratios here in this problem. Let's start by looking at the basic one. There's 14 non-commercial vehicles for 5 commercial vehicles. So let's write 14 to 5. And let's use an N for the non-commercial vehicles and a C for the commercial vehicles. Okay, so we have 14 non-commercial to 5 commercial. We'll start by making a tape diagram for that. Well, I will have 14 non-commercial vehicles. I'm going to need a long tape diagram for that one because that's a big number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, I have 14 non-commercial vehicles, and now I need my commercial vehicle one. So that's going to be 5. And there it is, 1, 2, 3, 4, 5. So we have our ratio of non-commercial vehicles to commercial vehicles. Well, now we got to look at what's asking us. It says if there were 108 more non-commercial vehicles than commercial vehicles. So that 108 is the amount that's more. Well, if we look at our tape diagram, what's more? Well, these sections right here are the sections that are more for the non-commercial than the commercial. So these right here are the ones that we're going to be looking at. These right here equal 108. Because those are the ones that are more. Well, how many sections are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that 108 is going to be split up or divided by 9. Since that 108 is going to be split up or divided by 9, we're going to get 12. So each section is 12. And if each of these sections is 12, that means the rest of these must also be 12. Because that's what makes it a ratio, is that all those sections are equal. Otherwise, it's not proportional. So if each section is 12, then we can just do our multiplication. For the non-commercial vehicles, we're going to do the 14 sections times the 12 for each section, and you're going to get 168 non-commercial vehicles. For the commercial vehicles, we're going to do the same thing, except we're going to have 5 times 12 because there was 5 in the commercial vehicles, which is going to give us 60 commercial vehicles. Okay, now that we've looked at our examples, it's time to do a few practice problems together. The first one, the ratio of number of people who own a smartphone to the number of people who own a flip phone is 4 to 3. If 500 more people own a smartphone than a flip phone, how many people own each type of phone? Well, our ratio here is 4 to 3. So let's make a tape diagram. Make our 4. There's our 4 for our smartphone, which we'll represent with an S. And then we'll make our 3 with a flip phone, which we will represent with an F. Now it tells us that there's 500 more people who own a smartphone. So that means that this one section right here, that is more, is 500. Well, if that one section is 500, the rest must be 500. So we can jump right to our multiplication. The smartphone has 4 sections. And if each one has 500, that would be 4 times 500, which is going to equal 2,000 people who have smartphones. Let's do the same for flip phones. This time there's 3 sections. And if 3 sections 500, it's going to be 3 times 500, which is going to give us 1,500 flip phones. So there we go. We found the difference between the two, since it told us that there was 500 more people. It told us the difference. Found out that one section equaled 500, so that means each section must equal 500. Since each section is 500, we did 500 times the number of sections. Okay, in our problem number 2, Sammy and David were selling water bottles to raise money for the new football uniforms. Sammy sold 5 water bottles to every 3 water bottles David sold. Together, they sold 160 water bottles. How much did they each sell? We'll start by figuring out our ratio. Well, Sammy sold 5 water bottles and David sold 3. So that means the ratio would be 5 to 3 for Sammy with an S and David with a D. But it's talking about how much did they sell together. So we're looking for a total. Well, let's draw our tape diagram to start. Sammy had 5. 1, 2, 3, 4, 5. And then David had 3. 1, 2, 3. Well, if the total is 160, how many total sections do we have that make that 160? Well, 5 for Sammy, 3 for David, gets us 8 total sections. And if we have 160 total water bottles, we can see how much is in each section by doing 160 divided by 8. Well, 160 divided by 8 is 20. So each section is 20. Well, if we know what each section is, then we can just multiply that times the number of sections. So for Sammy, she has 5 sections. 5 times 8 or 20 is going to get us 100. Whereas for David, it's 3 times 20 because he has 3 sections, which is going to equal 60. So there we can see how much each boy sold. Sammy sold 100 and David sold 60. Since we're looking for the total this time, we counted up the total sections to divide out of the total 160 total water bottles. Okay, it's time to look at problem number 3. Ms. Johnson and Ms. Sipple were folding report cards to send home to parents. The ratio of the number of report cards Ms. Johnson folds the number of report cards Ms. Sipple folded was 2 to 3. At the end of the day, Mrs. Johnson and Ms. Sipple folded a total of 300 report cards. How many did each person fold? Well, we have our ratio here of 2 to 3. And then we have our total of 300 report cards. Let's try solving this one without a tape diagram. It's told us that the total is 300, so we're working with a part to whole ratio. Well, we know the whole is 300. What is the total of parts we have? Well, we have 2 parts for Ms. Johnson and 3 parts for Ms. Sipple, so that's a total of 5 parts. Well, those 5 parts is going to equal a total of 300 report cards. So we're going to do 300 divided by our 5 parts. And when we do 300 divided by 5, we're going to get 60 report cards. So each part is 60 report cards. Well, we can take that 60 and we can use it to turn it back into our original ratio of 2 to 3 to find how the totals for each person. We'll start with Miss Johnson, which we'll represent with the J. She had 2 parts times the 60 of each part's total, and 2 times 60 is going to give us 120 report cards. Then we have Miss Sipple, which we'll represent with an S. She had 3 parts. Well, so we'll do 3 times 60 because 60 is how the total for each part we found. 3 times 60 is going to equal 180, which will be 180 report cards. Now, one way we can always check to make sure we're right, so we can go back to our 2 answers, 120 for Ms. Johnson and 180 for Ms. Sipple. We can put them together. 120 plus 180 gives us a total of 300. So we know we're on the right track because our 2 pieces come together to make our whole. Okay, let's look at our last example, number 4. At a country concert, the ratio of the number of boys to the number of girls is 2 to 7. If there's 250 more girls than boys, how many boys are there at the concert? Well, this time we're not looking at total, we're looking at how many more. So that's the difference between the 2 different parts, the boys and the girls. So we got to find the difference in our ratio. The difference in our ratio is the difference between the 2 and the 7. Well, the difference between the 2 and the 7 is we can just do 7 minus 2, which will get us 5. So the difference is 5 parts. There's a 5 parts difference. Well, we know this 5 parts difference is going to equal 250 because that's the difference between our 2 parts of the boys and the girls. So we know that the 250 has to equal 5 parts, so that way we can do 250 divided by 5, and 250 divided by 5 is going to equal 50. Well, now that we know how much each part is going to be, we can go back to our multiplication. For the boys, there is 2 parts. So 2 times 50 is going to equal 100. Total boys. For the girls, there's 7 parts. So 7 times 50 is 350. Oh, I'm sorry. 7 times 50 does equal 350 girls. So there we go. And we can check to see if our answer's on the right track because the difference between the 2 is 250. If we take 350, we minus 100, we get 250. So we know we're on the right track.